Assume each of the following represents a table of equivalent ratios. Fill in the missing values. Then choose one of the tables and create real-world contexts for the ratios shown in the table. I'm noticing that 22 and 44, they have a relationship because 22 is half of 44, which means whatever goes in this box needs to be half of 16, which is 8. I'm also noticing that 66 is 3 times 22, and 3 times 8 is 24. If I were to split this in half again, I would have 4 and 11. 4 times 3 gives me 12. So 11 times 3 gives me 33. 11 times 5 is 55. So 4 times 5 goes in that box, and that is 20. We'll come back to the context in a minute. Here I'm noticing that if we increased by 5, I would go 15, 20, 25, 30. And on this side, it looks like we're increasing by 7. 7, 14, 21, 28, 35, and then next we would have 42. If we work backwards here, we would have 10 and then a 5. We can check our work. 5 times 3 is 15. 7 times 3 is 21. 5 times 2 is 10. 7 times 2 is 14. 5 times 4 is 20. 7 times 4 is 28. 5 times 5 is 25. 7 times 5 is 35. Over on this side, or number 3, it doesn't look as obvious to me what the relationship is. So I might try and find the value of the ratio to figure out what is going on. I see 15 and 85 both end in a 5. So I can divide a 5 out. 15 divided by 5 is 3. 85 divided by 5 is 17. So that might be my first box, 3 and 17. How might I get from 17 to 34? Well, 17 times 2 is 34, and 3 times 2 would be 6. Here, from 34 to 51. Maybe there's a 17 in there. 7 plus 5. Nope. Oh, that should be a 4. 4 plus 7 is 11. 3 plus 1 is 5. So yeah, there's a 17 there. So that must be 17 times 3. Well, 3 times 3 is 9. 3 times 4 is 12. So what's 17 times 4? 4 times 7 is 28. 4 times 1 is 4. Plus 2 more makes 6. Now let's talk about the context of these. We get to come up with whatever we want the context to be. So maybe our relationship is something like, for every 4 blue marbles, there are 11 red marbles. For number 2, we can come up with a different scenario. Maybe in this one we're talking about cost of something. for 5 candies, it costs $7. So then for 30 candies, it would cost $42. And on number 3, we can come up with another situation. In the recipe, we need 3 scoops of chocolate to make 17 cookies. In each of these, there's a for every, or for each, or for some amount, there is something else. You want some type of relationship between the two of them, so that each time a new set occurs, both of them change by the same type of thing. So like on this one, 3 times 2 and 17 times 2. On this one, 7 times 4 and 5 times 4. They both get larger by being multiplied by the same number. 11 times 5 and 4 times 5. They're all increasing together at the same ratio.